All right, now that we've done a review of strength of solutions, we're ready to jump in and actually prepare some IV bags. So let's take a look at this first example. We're told next, suppose that you need to use this 20% stock solution to make 250 milliliters that is only 5% strength. You need to add water to a particular amount of stock solution until you have a total volume of 250 milliliters, which has the lower concentration. So that's the dilution we are doing. But how much of the stock solution do we need to use? Well, let's take a look at what we know for sure. We know for sure what the strength for the stock solution is. We also know the strength for the IV solution that we want to make. And we know the volume of the IV solution that we want to make. Well, what do we need to find? We need to know the volume of the stock solution that we need to use so that we can then fill the rest of the IV bag with water to dilute that stock solution and end up with the strength for the IV solution that we desire, that 5% strength. Well, how are we going to do that? One way that we could go about doing this is using dimensional analysis. And so if we're going to use the dimensional analysis to do this, we are going to start with the total volume of IV solution that we need, and then use dimensional analysis to figure out the volume of the stock solution we need. So we said if we start with the total volume of IV solution, well, we know that we wanted to make a 250 milliliter IV bag. So we are going to go ahead and start that we need 250 milliliters of IV solution. Well, we know from working with dimensional analysis that our goal is to get our units to cancel out here, because we aren't wanting to know how many milliliters of IV solution we need. We already know that. We are trying to get an answer of how many milliliters of stock solution do we need to make this IV bag. So our goal is to get the milliliters of IV solution units to cancel out. So we are going to go back and look at, well, what else do we know about the milliliters of IV solution? Well, we know what we want the strength of this IV solution to be, and we just reviewed how strengths of solutions work. So since we want our IV bag to be a 5% strength solution, that means that we are going to have 5 grams of medication per 100 milliliters of IV solution. That's the definition of a 5% strength. Now, in order to get the milliliters of IV solution units to cancel out, since we had those up top when we started, we put the milliliters of IV solution in the bottom so that these units then will cancel out here. Meaning that if we were to stop the problem right now, the number that we would be given is the grams of medication that we need to put in our IV bag. But that's not what we're looking for. We want to know the volume of the stock solution. So we're going to need to get rid of this new unit now, grams of medication. And so we're going to go back and look at what we know and see how what we know could relate to grams of medication. Well, we've already used the volume for the IV solution. We've used the strength for the IV solution, but we have not yet used the strength for the stock solution. So let's go back and look at what that was telling us. We said we had a 20% stock solution. Well, a 20% stock solution, we said, means that there are 20 grams of medication. There's that unit we're trying to get rid of, grams of medication. So we have 20 grams of medication per 100 milliliters of the stock solution. And so when we set up our next conversion factor, because we want the grams of medication unit to cancel out, we are going to go ahead and place that in the bottom. And then our other units are going to go up top, which was the milliliters of stock solution. And so here, our grams of medication units cancel out, leaving us in units of milliliters of stock solution. Those are the units we desire. And so when we go ahead and we do our multiplication here, we end up with our answer. that we need 62.5 milliliters of stock solution. And so if we take a look here, in our answer, we can say to make 250 milliliters of an IV solution with a strength of 5% out of a 20% strength stock solution, we're going to start with 62.5 milliliters of stock solution. And so we're going to put that stock solution into the IV bag. We'll fill the rest with water until we reach our 250 milliliter limit for this IV bag that we are making. An alternative to dimensional analysis can be found below. And if you wish to do something other than dimensional analysis, you can read through that and you're going to get to the same answer either way. Well, let's go ahead and take a look at a second example. So here in example number 2, we have using a vial with medication A and a strength of 100 milligrams per milliliter. You must prepare a 250 milliliter bag that is 0.1% strength. And so we said, if we're going to use dimensional analysis to help us prepare this IV bag, we're going to start with what we know about the volume of the bag. We know we need to prep a 250 milliliter IV bag. So we will go ahead and start. We need 250 milliliters of IV solution. Well, we said we want those units to cancel out. We're trying to get rid of the units that are milliliters of IV solution. And so we're going to go to, well, what is the strength of the solution of this bag? We want a 0.1% strength IV bag. We said working with strength of solution, that means we have 0.1 grams of medication per 100 milliliters of IV solution. And so we'll use the strength of the IV bag to set up our next conversion factor. We've got 0.1 grams of medication per 100 milliliters of IV solution. And so we knew we wanted the milliliters of IV solution to be in the denominator so that when we have the units of milliliters of IV solution in the numerator and in the denominator, those units will cancel out and leave us currently in grams of medication. Now, in this example, we run into a second problem in that our stock solution is not dosed in grams. If we look back, our vial that our stock solution, medication A, is in, is dosed in milligrams per milliliters. Well, right now we're in grams. So we need to go ahead and convert our grams of medication to milligrams of medication. So we'll use our conversion factor for grams and milligrams here. We know that there are 1,000 milligrams in 1 gram. We know that we're going to put grams on bottom here, so our units cancel out. Grams of medication cancels with grams of medication. And now we are left in milligrams of medication. So we're getting closer. We know how many milligrams of medication A we need. But that's not quite enough information because we need to know what volume we need to draw out of this vial with the medication in it. Well, on this vial, we were told that for every 1 milliliter, there are 100 milligrams of medication. And so we will use that for our final conversion factor here. We know that the milligrams of medication is going to have to go in the denominator so that our units will cancel out here. And then we are left in units of the milliliters of stock solution. That's what we are looking to find. How many milliliters of stock solution do we need to draw out of this vial? And so if we go ahead and do our math here, we get an answer of 2.5 milliliters of stock solution is what is needed to prepare this 250 milliliter IV bag at a strength of 0.1%. Once again, below here, guys, you have an alternative solution, an alternative method, rather than using dimensional analysis if you prefer that. But you should be ready to go and prepare some of your own IV bags now. So you're going to take a look at these final 4 problems in the activity, guys, using the 2 examples we just did together as as a guide to help you through. So give these 4 problems a look and see how they go.